Greetings internet users, I'm sure many of you have seen a shooting star at some point. The name itself is quite clear, it looks like a star falling from the sky, accompanied by a bright glow and leaving behind a luminous tail.
It happens fleetingly, within a second, and is an astronomical phenomenon of true beauty.
There are even times of the year when we can witness what is called a meteor shower or shower of stars. In such cases, it's possible to see up to 2 shooting stars per minute in clear skies free from light and pollution. The night sky has always intrigued us, and we are not content with just its beauty. We want to know more. We wonder where these shooting stars come from, some with distinctive brightness and different colors. Our planet Earth is constantly traveling through space, and it crosses the path where a comet or asteroid once passed many times. The solar system is filled with them everywhere. For example, comets, which are filled with icy materials, release gases and dust particles as they orbit the sun. When heated, all that material leaves behind a stream of tiny particles along the comet's path. So, when the Earth crosses that path, the remnants of the material are disintegrated in the atmosphere at high altitudes, around 80 to 100 kilometers above the surface, forming shooting stars. These types of meteors last for a short time, and their luminosity comes from the atmospheric ionization caused by their disintegration. The particles entering the atmosphere are no larger than a grain of sand. However, there are others with different sizes and chemical compositions. These meteors can disintegrate at altitudes between 13 and 50 kilometers, leaving an impressive flash of light. We observe that some of these meteors appear green, while others are red or blue.
Isn't that strange? The reason lies in the chemical composition of the icy meteor.
Each element it contains has the property of emitting various shades of color, and based on those colors, we can guess what it's made of. Generally, the colors are always associated with the same meteor shower. This means that if we are in the season to see meteors from the Lyrids, for example, all those meteors will be the same color because they come from the remnants of the same comet. The color red is primarily due to the presence of nitrogen and oxygen.
If they appear yellow or orange, they must contain sodium. Green is associated with magnesium, and blue with heavier elements like iron.
Additionally, yellow is also associated with this element. We also encounter shades like pink and violet, which are produced by calcium.
We can also find meteors that are composed of various materials.
When these meteors disintegrate, they emit light in the form of all these elements. Their atoms become free, and the reaction with the atmosphere during their disintegration causes all those colors of the visible light spectrum. Fortunately, we can perceive this without the need for instruments. It's a spectacle for the eyes. The majority of these shooting stars end up disintegrating in the atmosphere.
Meteors are not very dense or large enough to reach the surface.
So, how can we identify these meteors?
Depending on the time of year, the meteors will be visible in one direction or another.
However, if you're lucky, you can see a shooting star at any time of the year.
This is common for people who live outside city lights,
but there are moments that are more active, and we know exactly where they appear, so we prepare for that event.
In a meteor shower, we need to locate the radiant and the zenithal hourly rate.
It's good to know the speed of the meteors to determine if they are fast or slow, especially if you're doing astrophotography and want to calibrate the camera. Then we need to check the lunar phase to see if we'll have the best conditions of darkness or if we should wait for another event of this kind. A full or nearly full moon is detrimental for meteor viewing because it illuminates the sky too much.
And what is the radiant?
It's a point in the sky from which the meteors seem to emerge. The zenithal hourly rate is the number of meteors expected per hour, assuming we don't have a full moon and have clear skies without light pollution. For example, during the Perseids meteor shower, we know that it can reach 100 meteors per hour. Now, I'm going to show you the main meteor showers and their dates that can be seen throughout the year. These are the most well-known ones. The quadrantids occur between January 1st and 5th, with their peak on January 3rd. They are located in the constellation of Boötes, have a moderate speed of about 41 kilometers per second, and a zenithal hourly rate of up to 120 meteors per hour. They are one of the most important meteor showers of the year, and usually have a bluish color. They originate from the asteroid 2003 EH1, which is believed to have been a comet once. The Lyrids can be seen between April 16th and 25th, with their peak on April 22nd.
As their name indicates, they are located in the constellation of Lyra.
They have a rate of about 18 meteors per hour and are a weak shower with a moderate speed. They come from the long-period comet Thatcher and have a characteristic white color. The Perseids, also known as the Tears of St. Lawrence, are the most popular meteor shower. They can be found in the constellation of Perseus, with their activity period from July 17th to August 24th, but their peak occurs between August 11th and 13th. They can reach up to 100 meteors per hour and are high-velocity meteors meteors, reaching speeds of up to 60 kilometers per second. Their origin is the Swift-Tuttle comet, and they are often greenish-blue in color. The Draconids are located in the constellation Draco, and their activity occurs from October 6th to 10th, reaching their peak on October 8th. They have a variable zenithal hourly rate and a slow speed of about 20 kilometers per second. They originate from the Giacobini's inner comet and have a characteristic yellowish-red color. The Orionids can be seen near the constellation Orion, with an activity period from October 2nd to November 7th, and their peak occurs on October 21st. Their zenithal hourly rate is 23 meteors per hour, and they have a high speed of about 66 kilometers per second. They originate from the Halley's Comet and have a characteristic greenish-yellow color. The Leonids, as their name suggests, originate from the constellation Leo and can be seen from November 15th to 21st. They reach their peak of activity every 33 years. The meteor rate that can be seen is about 20 meteors per hour, with a high speed of about 71 kilometers per second. They originate from the Tempel-Tuttle comet. The Leonids are impressive not because of their activity, but because they are very bright meteors with a red color that leaves a green trail behind. The Geminids are seen from the constellation Gemini and are the highest activity meteor shower, although curiously not the most popular one. Their activity period extends from December 7th to 17th, with the peak occurring on December 13th. They can surpass 120 or even 160 meteors per hour, with a moderate speed of about 35 kilometers per second. They originate from the peculiar asteroid Phaeton, which many believe to be an extinct comet that shed part of its icy materials. Their characteristic color is a bright yellow. Our eyes can take between 15 and 20 minutes to adjust to darkness. It's good to bring a chair and a hammock and look in the direction of the radiant. Be patient, at any moment, those beautiful stars will appear, a spectacle for the eyes that we can witness from our Earthship in its orbit around the sun and throughout the galaxy. If you liked this video, give it a like and don't forget to subscribe and leave your comment.